Okay, let's try the next two examples. So we have y equals negative 2x plus 1. So again, just as before, I'm going to pick negative 2, negative 1, 0, 1, and 2, just because they're close to the origin, and it just makes it a little bit easier for us. And then as I figure out the y values, what I'm going to do is I'm going to replace x in this equation with the value that I've selected there and see what y is. So here it says to do negative 2 times the x value, which is negative 2 plus 1. So negative 2 times negative 2 is positive 4, plus 1 is 5. All right, be careful with that. That's where I think you're going to make your mistakes. Not plugging it in, but just maybe doing the wrong sign on the integers. Okay, the next problem says that our y value is obtained by doing negative 2, again from this, times our x value, which is negative 1 plus 1. Negative 2 times negative 1 is positive 2, plus 1 is 3. The next one we're going to do negative 2 times 0 plus 1. And we get 0 plus 1, which is 1. Then we do negative 2 times 1 plus 1. Negative 2 times 1 is negative 2, plus 1 is negative 1. And then the last one is negative 2 times positive 2 plus 1. Negative 2 times positive 2 is negative 4, plus 1 is negative 3. So when we look at our x values, again, they're split symmetrically around the y-axis. So just like before, I'm going to do an even amount between the y and the x, or I'm sorry, the positive and the negative on the x-axis. And here they're kind of split, again, fairly equally, maybe a little bit more top-heavy on the positive y's, but they're split pretty evenly on the positive and negative y-axis. So I'm going to do my x-axis a little bit more centrally located this time, instead of like I did the other times where I kind of mostly did just the top part. And again, I'm going to mark my axes. Again, hopefully you're doing this on graph paper. So 1, 2, 3, 4. 1, 2, 3, 4. I'm going to do by 2s. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so then I'm going to graph them. So when x is negative 2, y is positive 5. When x is negative 1, y is positive 3. When x is 0, y is 1. When x is 1, y is negative 1. And when x is 2, y is negative 3. And again, you get a nice line there when you connect the dots. If I could draw it straightly, that was a little bit wiggly, but hopefully you did a better job than I did. All right. And then let's take a look at the last one. Now, this last one I'm going to do a little bit differently because of the 1/2. If I were to choose the same values that I did before, negative 2, negative 1, 0, 1, and 2, we'd be fine when we plugged in negative 2 and positive 2, because I can easily take half of negative 2 and half of positive 2. I'd be fine also at 0, because half of 0 is 0. Anything times 0 is 0. But when I get to the negative 1 and the positive 1, I'm taking half of 1, and I'm going to get a half and have to add that to 3. I don't feel like doing that. I can do it, but I don't want to do it. So instead this time, instead of choosing negative 1 and positive 1 in here, we have two different options. One is we could just skip them altogether, but here's what I'm going to do, just because I want to get those 5 points, again, just for more practice. So I'm going to choose negative 2 and positive 2, but instead I'm going to choose something else that 2 goes into, all right, because then I can take half of it and get a nice number. So I'm going to choose negative 4 and positive 4. Right. Again, you're free to choose negative 1 and positive 1. The downside of that is that you get fractions, which most people try to avoid. But that would keep your values of x consistent with the ones that we've done. All right, so choosing negative 1 and positive 1 keeps that all the same, but you get fractions. The other thing is we could just ignore the positive 4 and negative 4. That absolutely is an option, but I'm not going to choose that because I want you to practice evaluating, so putting the x values in and getting the y. But when you do this on your own, 3 points is plenty if you get a fraction like this and you want to skip those 1 and -1 values. The third option, which I'm going to choose, is that we just choose a different x value that is divisible by 2 so that we can take half of it. All right, so let's do that. So then this says, in order to get our y values, we take half of our x value, which in this case is -4, and then we're going to add 3. So half of -4, again, be careful with your signs here. Half of a negative number, +1/2 times -4 is -1/2, I'm sorry, let me say that again. Half of -4 is -2. -2 plus 3, let me write that, -2 plus 3 is 1. Right, half of -2 plus 3, half of -2 is -1, plus 3 gives us 2. Next one, half of 0 plus 3, half of 0 is still 0, plus 3 is 3. This one, half of 2 plus 3, half of 2 is 1, plus 3 is 4. And then half of 4 plus 3, half of 4 is 2, plus 3 is 5. All right, now, again, I'm going to go around the x-axis here so that I have 2 negative values, 2, 3, 4, -4, -2, and 2 positive values, 2, 4. But then I'm going to leave most of my room on the y-axis up top and skip down the bottom here. So 1, 2, 3, 4, 5. And again, technically we put arrows on the end here to indicate that it keeps going on forever. I don't always remember to do that, but technically we should. Okay, so I plot the point -4, 1, and then -2, 2, and then 0, 3, and then 2, 4, and then 4, 5. Again, we get all of them on a nice straight line. Now, I want to talk about this in a future video, and I'll just mention it right now. I'm sure that you noticed when you wrote your x values and your y values, obviously your x values followed a pattern, -2, -1, 0, 1, 2. They kept increasing by 1, but hopefully you noticed a really kind of cool but different pattern in each of these. So in problem number 1, or first one, y equals 2x plus 3, did you notice that each time that you increased your x value by 1, right, from -2 to -1 increased by 1, from -1 to 0 increased by 1, from 0 to 1 increased by 1, from 1 to 2 increased by 1. Every time we increased by 1, our y values increased by 2. From -1 to +1 is 1. From 1 to 3, sorry, I can't remember what I just said there. From -1 to +1 is an increase of 2. From 1 to 3 is an increase of 2. From 3 to 5 is an increase of 2. From 5 to 7 is an increase of 2. All right? If we look at this one, every time we increase by 1, again, from -2 to -1, increase by 1. -1 to 0, increase by 1. 0 to 1, increase by 1. 1 to 2, increase by 1. Here, what was happening was we decreased by 1. All right. Then here, every time we increased by 1, we decreased by 2. All right, 5 to 3 goes down by 2. 3 to 1 goes down by 2. 1 to -1 goes down by 2. -1 to -3 goes down by 2. Right, up here, or sorry, over here, the last one, here we increased by 2. Here we increased by 2. Here we increased by 2 and increased by 2. In the y values, we increased by 1, increased by 1, increased by 1, increased by 1. I'm not going to tell you what the significance of this is, but I want you to think about it. It's not completely obvious. It will be once we do more of these, but I want you to save these and kind of this note that you wrote here, because I want you to keep looking at that and keep paying attention to that. And I am going to tell you what the pattern is, but I just want us to have more data points. So far we've done 2 problems. Actually, we can turn over and look at the one that we did right here also. This was the y equals x plus 2 that we did on one of our first videos. These all increase by 1, and so forth, increase by 1, and here these also increase by 1. So now we have 5 problems. The reason I'm telling you this is because eventually we would like to get to the point where we don't have to plot points to graph, where we can just say, hey, I know what the pattern's going to be, and you'll just be able to just kind of look at the equation and know what the graph looks like. So this is one part of it, all right? The other part that I want you to look at is, where does it cross the y-axis, all right? So if we look at this one that was 2x plus 3, where does it cross the y-axis? What's the value? All right, it should be at y equals 3. All right, where do we cross the y-axis here? Should be y equals 4. Right? Where do we cross the y-axis here in this one? Y equals 1. Where do we cross the y-axis here? Y equals 3. And again, let me flip back to the other one. Where do we cross the y-axis here? Y equals 2. Is there something, a way that you could predict that based on the equation that you're given? Is there some relationship between where it crosses the y-axis here and the equation that you're given right here? Where it crosses the y-axis here and the equation that you're given here. All right, so these are all things I want you to kind of think about. Also, notice how sometimes as you read this from left to right, the line's going up, right? So for example, down here, it's going up. And sometimes as you read from left to right, it's going down. As you read from left to right, it's going down. So why does that happen? What is it about the equation that makes that happen? These are all things I want you to think about. So why does it go up sometimes versus down? What's the significance of where it crosses the y-axis? Where do you see that in the equation? And is there a way that you can understand this increase in x versus increase in y with the equation? All right, so think about those things and we will talk about them in future videos. Bye.